our own galaxy has about 10 to the 11th stars. As I said, some people think it's a bit more than that. One point I like to bring up with my 100 level students is just how many planets that might imply. We know from recent observations that there's about one planet for every star. So there's about 100 billion planets in our own Milky Way, which in and of itself is one of maybe 100 billion other galaxies in the universe. So there's a lot of other possible planets. This picture, by the way, is my preferred method, or my preferred image for showing the Milky Way galaxy. This is an artist's rendition of our galaxy based on real astronomical data. So we can quibble about different aspects of this that maybe aren't completely correct, but it's in general how the Milky Way would look if we were way above the galaxy looking down on it. So here's the sun, again, kind of on the outskirts. This is the center of the galaxy here. This is a bar. Many spiral galaxies have bars. And you can choose with your little radio telescope to look anywhere in this plane or anywhere out of the plane. Just depends on where you point the telescope and what time of day it is.
That rendition represents just all matter, not dependent on visibility, it's just whether there's matter there or not.
There's some visibility information. So you see these dark lanes, that again is from dust mixed with molecular gas. You see these little red things. These are H2 regions. And they are painted red because of what's called H-alpha emission. There's a really bright emission line that's observed at 656 nanometers in the red part of the spectrum, as you see with your eyes. And then the stars are kind of white. They kind of look white with our eyes. So this is not a true color image. This is not what you actually see with your eyes, but there is information here that tells you something about what you would see. So it's not entirely a false color.
I guess what I'm asking is, what if we got rid of visibility and just said, okay, we're going to represent matter?
Yeah.
And maybe use a color scale to represent density of matter, regardless of what the substance is.
Right.
Dust, hydrogen gas,
right.
Whatever.
It would look not so dissimilar from this. You kind of defocused your eyes because the matter distribution is smoother than this. But you could see small enhancements along the spiral arms, but generally a smooth distribution, and then you could see the center of the galaxy.
Yeah, I guess my curiosity is are these spirals dense, more dense regions of matter?
Yes.
Not just visible or whatever.
That's right.
Matter.
It's a very small overdensity, but yes, they are overdense by about 5 or 10% in the stellar mass, and by tens of percents, I forget the number, in the gas mass. Another question. Yeah?
Are stars being hidden in the lanes?
Yes.
We can't see. So there are stars, but in this picture, we can't see.
Yes, there are. Our ability to see stars is actually hampered by the gas and the dust. And so if you think back on that first picture of the Milky Way, where there's those dark lanes, those are not real physical decreases in the number of stars. It's just that there's a screen there, and there's something behind that we can't see. So within our own galaxy, it becomes difficult to see the stars the further you go. And so a lot of this image is simply extrapolated. So we can assume that there's symmetry in the galaxy, and if we see the stars in one part, we can assume that it's symmetric on the other part. But yeah, we cannot find all of the stars in the Milky Way. Good questions, guys. All right, here's another image just to highlight that the galaxy is a plane. Here is our plane here, and then we can see out of the plane or we can look along the plane. And again, we'll reiterate these points later. Here's yet another view of the Milky Way. When you guys are in Green Bay, you will have much better skies than here in Morgantown. For one thing, the humidity will be less. And humidity actually is a killer for observing the Milky Way. It's really hard if there's an overall haze to make out this band of stars and dust. But when you're down there, hopefully you'll have some clear skies. You'll be able to see it. It's really spectacular. More prominent in this image is the dust that is blocking out the starlight. Again, there are stars uniformly, more or less, along this band, but we have something blocking our view of them. This here is the center of the galaxy. We have more stars toward the center of the galaxy than in other parts of the galaxy.